So this is part 4 for the algebra and trig review. So finally getting into some trigonometry problems, and number 8 for this series, I guess, of problems. Find the exact value of the following. In part A is tangent of pi over 3, part B is sine of 7 pi over 6, C is secant of 7 pi over 3. So you should already be familiar with the unit circle and the concepts of tangent, secant, sine, cosine, cotangent, and all that fashion. So for part A, I know that tangent is sine over cosine, so I have tangent theta is sine over cosine theta. So, and if I have, in this case, theta is pi over 3, and if I have the unit circle, so pi over 3, somewhere like right there, and on the unit circle, you have the x value and the y value for that point. And for the x and y value for that point, I believe it's going to be, hold on, it's 1/2 comma square root of 3 over 2. All right, and your cosine value is the x coordinate, the sine value is the y coordinate. All right, this is all review from trigonometry class. So if I have tangent of pi over 3, that's sine of pi over 3 over cosine pi over 3. Well, sine of pi over 3, that's square root of 3 over 2. Cosine of pi over 3 is 1/2. And then if I do square root of 3 over 2 divided by 1/2, these 2's divide out. So you have basically square root of 3 over 1, which is square root of 3. All right, so the answer is square root of 3. All right, and I'm not looking for any work for this. You just know how to get the answer. This is just the thought process that goes in my head to do the problem. So I usually reference a unit circle, find the sine and cosine values, and then apply what the definition of tangent is. Now 7 pi over 6, again, I'll reference the unit circle. So that's going to be somewhere like right there. That's going like this counterclockwise. So that's going to be 7 pi over 6. And the point has the coordinates negative square root of 3 over 2, negative 1/2. And again, cosine is the x coordinate, sine is the y coordinate. The y coordinate's negative 1/2, so sine of 7 pi over 6 is going to be negative 1/2. All right, that's how I do that one. Now, part C is secant of 7 pi over 3. All right, so some preliminaries, I have to know, well, what is secant? Secant of theta is the reciprocal of cosine, 1 over cosine of theta. So secant of 7 pi over 3, that's equal to 1 over cosine of 7 pi over 3. And then you'll notice that on the unit circle, you don't have 7 pi over 3, but if I go complete revolution, that's 2 pi. 2 pi is the same thing as 6 pi over 3. 6 divided by 3 is 2. So if I wanted to go to 7 pi over 3, I just go pi over 3 more, and that puts me at the same position as what pi over 3 would do. So going around complete revolution and then pi over 3 more than that, that puts me at 7 pi over 3. It's the same position on the unit circle as just pi over 3. And that's got coordinates 1/2 comma square root of 3 over 2. Again, so all right. So 7 pi over 3 puts you at the same position, same spot. It's pi over 3, right? 7 pi over 3 is just pi over 3 more than 6 pi over 3, which is 2 pi. All right, and so cosine is the x coordinate at that point. So cosine, and then sine is the y coordinate. We only care about the x coordinate since we're dealing with cosine. So this will be equal to 1 divided by 1/2. Well, the reciprocal of a half is 2. That's going to equal 2. And that's going to be our answer is 2. Okay, so that's that one. And again, you don't really need to see work. It's just this is a thought process that's going in my head to do the problem. All right, so that's number 8. This next one's going to be number 9. All right, so I'm going to solve. Sine of 2x equal to sine x. So I would make a comment. Is there any identities that we can use to simplify sine of 2x since it's got that 2 next to the variable x? So are there any? And so yes, there's the double angle identity. That's sine of 2 theta is equal to 2 sine of theta cosine theta. So we can change this. Instead of sine of 2x, we can change it so it's 2 sine of x cosine x and then equals sine x. And then we're going to put everything on one side of the equality. So put everything on one side so it equals 0 on the other side. All right, and I'm going to subtract sine x from both sides, so I have 0 on the right side. That's going to give me 2 sine x cosine x minus sine x. Equal to 0. Then I'm going to factor. And I can factor out sine x. That's going to leave me with 2 cosine x minus 1, and then equals 0. All right, I have 2 factors, which means I have 2 scenarios. And the 2 scenarios, scenario 1 is sine of x equal to 0. Scenario 2 is 2 cosine x minus 1 equal to 0. All right, and I asked myself, when is sine of x? Like, when do we have it so that the when you take the sine of some angle that you get 0? So when is sine equal to 0 on the unit circle? It's when theta equals 0 or pi. All right, because I have a unit circle right here, right here. That's going to have 1 comma 0. This one's negative 1 comma 0. Again, sine is the y coordinate. This is the same as if I were to take the inverse sine of both sides. So I know that sine of x equals 0 when x is 0 and pi. All right, and this is when you're only doing one revolution, and that's the same thing as saying 0 less than or equal to x less than 2 pi. And in general, if we were to go an infinite amount of revolutions, we would see that sine of x equals 0 when x is, so you could have, so infinite amount of revolutions. If I go one revolution, that's got 0 and pi. If I go 2 revolutions, that's going to give me 2 pi and 3 pi. So essentially it's going to be, I could have it be like, for instance, so it could be negative pi, 0, pi, 2 pi, 3 pi, 4 pi, keeps going. Likewise, I could have it also be negative 2 pi or negative 3 pi. And it's all these integers. So we would say sine of x equals 0 when x equals n times pi, where n is an integer. Right, that means n can be -2, -1, 0, 1, 2, it keeps going. All right, this is called the general solution. If they defined an interval in the question, if they specify solve for when x is between 0 and 2 pi, then the specific solution for this part of the question is just 0 and pi. All right, that's if they ask for a specific solution. All right, so I'm going to box that just to say sometimes this depends on the wording. I didn't specify in this, I just said solve, which generally if it just says solve and they don't specify an interval, then you just use the general solution. Now, mind you, this is only for the first scenario when sine of x is 0. Now for the second scenario, if I were to solve this, I would add 1 to both sides and then divide by 2. So if I add 1, that gives me 2 cosine x equal to 1. Then I divide by 2. That means cosine x is 1/2. And then I ask myself, when is cosine 1/2 on the unit circle? Again, this is confining ourselves to just one revolution, or confining ourselves to 0 to 2 pi. And that's just what the unit circle gives. And then from that, I can come up with a general solution. And you'll see that you'll have two possibilities. It's either pi over 3. That's where you have 1/2 square root of 3 over 2. And then cosine is just the x coordinate of that point. And then the other possibility is at, let's see, 5 pi over 3. And that's 1/2 comma negative square root of 3 over 2. And again, cosine is the x coordinate of that. So cosine of x equals 1/2 when x is pi over 3 and 5 pi over 3 if we had x between 0 and 2 pi. That's the specific solution. But in general, we go an infinite amount of revolutions. Let's see, so I'm going to say doing an infinite amount of revolutions. A revolution means you go complete revolutions to pi. So in general, doing infinite amount of revolutions. So it's when x is pi over 3 plus 2n pi. So n is an integer. And then x being 5 pi over 3. Also plus 2n pi, where n is an integer. So n can be like -2, -1, 0, 1, and 2. I'm just putting dot, 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 because it goes on further to the left. So it'd be -2, -1, 0, 1, and 2, dot, dot, dot. All right, that's the general solution. Let me zoom out. Now for the first scenario, that was for the second scenario, but for the first scenario, it was n times pi, because for one revolution, it's either 0 or pi, and then if you keep going around and around, it'll be like 2 pi, 3 pi, 4 pi, 5 pi, so forth, and then the other direction will be negative pi, -2 pi, -3 pi, -4 pi, and that's why I just express it as n times pi. Whereas with this one, I had to do it as 2 times n times pi, since they're at kind of different spectrums, to where they're not necessarily multiples of one another. All right, now if I combine the two scenarios together, we would have the general case. So x is n times pi, that's scenario 1. And the other case was pi over 3 plus 2n pi. And then 5 pi over 3 plus 2n pi. All right. And again, this is scenario 1. And these two were scenario 2. Now, the specific case is if it was defined for one revolution. So this will be if 0 is less than or equal to x less than 2 pi. Then we'd have x is equal to 0, pi over 3 pi, and then 5 pi over 3. And the 0 and pi part came from scenario 1. And then the pi over 3 and 5 pi over 3 came from scenario 2. So it really depends on what they ask, but that's going to be the answer. It's either the general case or the specific case. All right, so just to recap, it was solved sine of 2x equal to sine of x. I first use a double angle identity so that I can change it so it doesn't say sine of 2x anymore. That way it just has just x that you're for the argument of the trig function. So I change it to 2 sine x cosine x. Subtract sine x from both sides so I can have it set equal to 0. Then I factored out sine, and that gave me two factors. Scenario 1 was sine of x equal to 0. Scenario 2 is 2 cosine x minus 1 equal to 0. And then for scenario 1, I asked myself, well, when is sine 0 in the unit circle? That occurs at 0 and 2 pi. Now this is just for one revolution, which is the same thing as saying x is between 0 and 2 pi. Now for in general, if we were to go an infinite amount of revolutions, so not just one revolution, and you can go in both directions, either counterclockwise or clockwise, x is going to be like negative pi, negative 2 pi, negative 3 pi, or pi, 2 pi, 3 pi, and you notice that they're all integers, multiples of pi. So in general, we'd say sine of x equals 0 when x is n times pi, where n is an integer. All right, that's the general solution for scenario 1. And like I said before, the specific solution is 0 and pi. And that's if they tell you x is between 0 and 2 pi. They usually tell you this in the question. I did not specify, but I figured I'd go ahead and discuss both. Now, that was scenario 1. Scenario 2 was 2 cosine x minus 1 equal to 0. And then I add 1 to both sides and divide by 2. So that way I have cosine by itself, so it's cosine x equal to a half. And then a similar thought process. When is cosine a half on the unit circle? And it occurs at pi over 3 and 5 pi over 3. Because those 2 points give you x coordinates of a half. So then I said, well, cosine x equals a half when x is pi over 3 or 5 pi over 3. That's based on one revolution, which is between 0 and 2 pi, and that's the specific solution. Now, if we want to make this in general terms, meaning we go an infinite amount of revolutions, you could either go 2 pi of pi over 3 or 2 pi of 5 pi over 3. So that's why it says pi over 3 plus 2n pi. N is an integer, so it can be negative or positive. And then same thing for pi over 3, 2n pi. N's an integer. All right, so that's the general solution. And then this is the specific solution. So that's where each scenario was. And then I just combined the two together to say, well, combining the two scenarios, we have the general case, x equals n times pi from scenario 1. Scenario 2, we had pi over 3 plus 2n pi, and then 5 pi over 3 plus 2n pi. And again, n is an integer. If we had a specific case, specific solution, and they told us that x is between 0 and 2 pi, meaning you're only one revolution, then we have these 4 values for x. And I just put it in ascending order. All right, and that's where I'll stop this video. So this was the part 4. I'm going to make one that's for part 5.